Hello, my name is Matt Peters. I am an application development specialist with 3M, and today I'm going to talk to you about how to run a 3M Polisher ST trial. Step 1. Come up with a plan. 3M Polisher ST features a novel new ligand containing positively charged guanidinium functional groups. These groups feature a large resonance structure which stabilizes the positive charge and are capable of multiple electrostatic-like interactions such as forming salt bridges and hydrogen bonding with carboxylic acids. These interactions allow for high salt and low pH tolerance, but may also lead to unexpected interactions with your MAB if you are too close to it, or especially its acid variance, PI. Therefore, it is important to survey 3M Polisher ST's performance over a range of pHs and conductivities initially. We recommend the minimum pH to be greater than 5 or 5.5 if NVM clearance is important, and the maximum pH to be 0.5 pH units lower than the PI of the MAB. Conductivities can range from 3 to 20 millisiemens per centimeter, with a minimum of 5 millisiemens per centimeter recommended if NVM clearance is important. Higher conductivities are possible but may result in decreased HCP clearance. Please note that 3M Polisher ST cannot be used with water alone. A minimum conductivity of 3 millisiemens per centimeter is required for all solutions. We also recommend loading to approximately 3 to 4 kg per meter squared while doing your initial survey, as 3M Polisher ST typically reaches a steady state by this point. Once the ideal pH and conductivity are determined, loading and scaling studies can be performed. 3M recommends a safety factor of 25% for the loading to account for variations in the capacity of the membrane. For example, if the desired loading is 10 kg per meter squared, samples to greater than 12.5 kg per meter squared loading should be run. Here's an example of a simple DOE for a hypothetical MAB with a PI of 8.5, where we look at 3 different pHs and 2 different conductivities. Ideally, the sample at pH 7.5, 7 millisiemens per centimeter should give the highest clearance. However, if a sample with a lower pH or higher conductivity shows better clearance, it may indicate interference from your MAB and thus should be avoided. Even a difference of 0.5 pH units or a few millisiemens per centimeter conductivity can make a big difference and should be tested should interference be suspected. Obviously, the exact parameters of the DOE can be tweaked depending on what the incoming feed solutions look like or what flow-through conditions would be most helpful for subsequent polishing steps. Step 2. Get to know your capsules. 3M Polisher ST comes in a variety of sizes depending on the amount of MAB needing to be processed. Each capsule consists of 3 parts: an inlet, an outlet, and a vent. Note that on the BC1 capsules, the inlet and vent are interchangeable. For the BC4 and BC25 capsules, the inlet is directly over the outlet. For the BC170/BC340 and BC1020 capsules, the inlet is slightly higher than the outlet. Also note that there is an arrow on both inlet and outlet showing the direction of the flow path. At the recommended loading of 10 kg per meter squared, the amount of MAB in grams loaded is approximately equivalent to the capsule name. Recommended flow rate is 1 ml per minute per centimeter squared, or the capsule name in mils per minute, and the maximum differential pressure is 35 psid or 2.4 bar. Higher flow rates are possible provided you stay below the maximum differential pressure. A preconditioning flush of 5.4 mils per centimeter squared is required before use. The flush should be using the loading buffer. Step 3. Running a sample. The next video will go over how to connect a capsule to a pump or a FPLC. We'll use a BC1 capsule as an example, but the basic procedure is the same for all capsule sizes. First, cap or otherwise close the outlet of the capsule. Attach the appropriate tubing to the inlet of the capsule and start to flow at the recommended flow rate. You may want to tilt the capsule to ensure the vent is vertical. When liquid starts to come out of the vent, tap the capsule gently a few times to ensure there are no trapped air bubbles present. It is especially important for the BC1020s to ensure there is no trapped air between the three lenticles. Once fluid is coming out of the vent and all air is removed, open the outlet and cap the vent. For the laboratory scale devices, you can invert the capsule to remove air bubbles from the outlet. If needed, attach the appropriate tubing to the outlet once fluid starts to flow out of it. Proceed with the preconditioning flush, or, if necessary, base sanitization followed by the preconditioning flush. The capsule is now ready for use. For additional information, please contact your local application engineer. Thank you.